Hello and welcome to the video lesson on optimizing 3D solids. If you watched video 1, then you got the basic foundation of how to figure out what is the best solid, and this is a quick recap of that. The idea is that in 3D, when we're finding the best or optimal solid, it means we're picking the one that has the most volume, which can also be stated in terms of looking for the smallest surface area. So how do we pick that shape? Well, just like in 2D, there are two guidelines to follow. The first one is that if you can choose the solid, you choose the one with the most surfaces. And theoretically, the solid with the most surfaces possible is a sphere. It has infinitely many tiny little surfaces. If you can't choose the number of surfaces, then you want your solid to be as regular as possible. And just like in 2D, regular means that as many surfaces or lengths or dimensions are equal as possible. So if you can choose the solid, you choose a sphere. If you can't, then you make as many sides equal as possible to make as many faces equal as possible. So examples of types of questions you could see, you could have something like this, a question that says find the solid whose volume is whatever and has the smallest possible surface area. So if it just says find the solid and it hasn't specified anything about it, and we know that we're looking for the ideal solid because we have a given volume and we want to minimize surface area. If you get to choose, then the one to choose is a sphere. And in example 2, find the rectangular prism whose surface area is blah, blah, with the largest volume, then we don't get to choose the shape. A rectangular prism means that it has to have a rectangle as a base, and it has to be a prism, so have all straight lines connecting to its other base. And it is important to note that if we want a rectangular prism to be ideal, to have the most volume or the least surface area, we want all the sides to be equal. And that shape or solid is called a cube. So a cube is a subset. It's a type, a very specific case of a rectangular prism. That's important to keep in mind. So lastly, there are some mathematical calculations that you will have to do over and over again in these types of problems. And here they are. There are 4 of them. It'd be a good idea to take note of those. So here's the first. Because we're dealing frequently with spheres and cubes, the first thing you'll have to do is find the volume of a sphere knowing its surface area. So in this example that I've given, suppose the surface area of a sphere is 50 centimeters squared. What is its volume? And if you want to pause the video and try to work backwards, now would be a good time because I'm going to go through the answer in a minute. The first thing you need to do, because we're given the surface area, is to start with the surface area formula. And the surface area formula for a sphere is 4 pi r squared. And I'll replace what I know, which is 50, that's the AT. And you'll note that there's only one unknown that's going to be left in that formula, so I'll be able to solve for r. If you want to practice that, now's a good time to pause. I'm just going to show the answer. So if you plugged in 50 and you solve backwards, you isolate r squared, you take the square root. It means that our radius is approximately 1.99. I keep 2 decimal places. I'm going to keep my entire irrational answer with all the decimal places when I plug into the next step, because the actual question was to find the volume. Now that I know the radius, I can plug into the volume formula, which for a sphere is 4 pi r cubed over 3. And again, if you want to pause the video and give it a try, see if you get the right answer. I'm going to skip to the answer now. My answer was approximately 33.25 centimeters cubed. So that's one type of calculation you could have to do. If a question is asking what's the maximum volume of any solid whose surface area is 50 centimeters squared, we would know that because it's of any solid, you get to choose, and we would choose a sphere. And so we would have to find the volume of a sphere from its surface area. That's how you do that. Number 2, the second type of calculation that could come up is you could be asked to find the surface area from the volume. And a question like that would look like, what is the minimum surface area of any solid whose volume is 200 centimeters cubed? If you want to pause and give it a try, now's the time. But here, because we're given the volume of a sphere, I'll start with the volume formula. My first step is going to be volume equals 4 pi r cubed over 3. And if you want to try doing the math on that, now's a good time to pause. I'm going to skip to the answer. If I isolate for r, I would have to multiply both sides by 3. divide both sides by 4 and pi. Depending on your calculator, you might need to use brackets there. And then take the cube root. And so my radius is approximately 3.63. And next, because the actual question was asking for the surface area, I'll plug that into the surface area formula for a sphere, which is surface area is equal to 4 pi r squared. And if you want to practice that math, now's a good time to pause. That answer is approximately 165.39 centimeters squared. And those are the two working from the volume to the surface area or surface area to volume ways that you could have to deal with a sphere. And the last two examples are dealing with something that is not a sphere. Often, if you are asked to find the ideal or optimal rectangular prism, that's going to be a cube. So we'll often be working with cubes. So the exact same two things, you could have to find the volume from the surface area and vice versa. If you want to pause and give this one a try, it says that the surface area of a cube is 96 centimeters squared. What is its volume? I'm going to start going through the answer. What is important about a cube is that it is a rectangular prism. So given the surface area, I know that the area formula is 2ab plus perimeter base times height. But I also know that a cube has all side lengths equal to x, the length, the width, and the height. So when I first replace those in, this is what I would get. My area base is going to be x times x. My perimeter of the base is 4x, and my height is x. And it turns out that that allows me to simplify and come up with like terms. This first part of the expression is 2x squared, and this next part is 4x squared. And those are like terms, and I can add them. It means that my area total, that 96, is going to equal 6x squared. So I can solve for x that way. The same way of getting that answer would be a slightly different way of looking at it. And we know that a cube has 6 bases and that they're all equal. So if we divided that 96 total area by 6 equal faces, I would know that each individual square had an area of 16, and I could have solved that way as well. And finally, because the question asks for the volume, if you want to pause and give it a try, see if you can find it. The volume formula for a prism is area of base times height, and now we know that the area of the base and the height are made up of side lengths of 4. So the total volume of that shape would be 64 centimeters cubed. And finally, you could be asked to find the surface area from the volume. If you want to pause and give this one a try, now's a good time. This example says the volume of a cube is 81 centimeters cubed. What's its surface area? Because we're given the volume, I'll start with that formula. And like we already said, a cube is a particular shape in that all of its lengths or measurements are the same. They're all x. So when I plug in, I would get volume equals area base would be x times x. It's a square, and the height is also x. So it turns out that my side length is 3, and if you want to pause to find the surface area, if you want to give that a try, now's the time. The surface area formula we know is 2 area base plus perimeter base times height. And when you plug in, this is what you get. So those are the different types of calculations that will come up. And remember that the first thing you'll have to do is to identify what type of solid you're dealing with before you do that math. Thanks for watching.